Hey, good morning guys. I'm Brian Stabino and I'm the instructor here. And today what we're going to be doing is going over a lesson on how to weld thin sheet metal and thick steel. Now, that's a really good skill to have in your toolbox as a welder, because now we're getting more and more welding done out in the field, especially with thin sheet metal. There's a lot of times we're either welding metal studs together, or we're doing some conveyor work where we're actually welding on the sidewalls, and that's generally like a light steel gauge. So you're going to want to know how to do this with a stick welder. Not all the times. Now, if you're like at a PDM or something, or a shop where they have a MIG box, it's great. You're in an indoor environment. You're set up for like thin sheet metal welding. But out in the field, you're just going to have the big old welder, right? Like where you're working at now, Marcus, down at the Navy Yard, do they have a MIG box?
No.
No. So if you're doing any thin sheet metal welding, you got to do any stud welding or anything that's light gauge, you're going to be using just your regular propane welder. So what I'm going to tell you guys today is about how the rod selection you're going to use for thin sheet metal welding, the way you set up your machine, and then we're going to go over the different weld symbols, and then on the different angles and travel speeds that you have to know to do thin sheet metal welding. So the first step is understanding what style of rod or what rod selection you're going to use for a thin sheet metal welding. So generally in the field, when you're using a welding machine, you're going to either choose 60-13 or 60-11. They're good rods for welding sheet metal or thin sheet metal with thick steel. And with the 60-13, right here, you guys know the 60 stands for the tensile strength, right? So it's 60,000 pounds per square inch. The 1 out of there, that's the position. So that means I go weld either horizontally, vertically, or overhead. And then the 3 has to do with the flux. So 3, it's not a real low grade flux around the weld. It's got a little bit, so it's got a little bit more iron in it, a little bit more metals into it. Not much, but just a little bit. And generally wise, it's also like a drag rod with the 60 series. You guys know on 60-10, that's whip and pull is. The 60-13 and the 60-11, they're like a drag rod. And then the other thing, knowing what rod selection to do is your amperage, how to set the heat on the machine. So generally with a 60-13 332 rod, you're going to set your amperage around anywhere from 40 to 90 amps. And then the 60-13 1/8 inch, which is what I have in my hand, this is 1/8 inch thick, and that all has to do with the thickness of your electrode, not just your flux, but just the electrode. So with the 60-13 1/8 inch, you're going to generally set your amps from 90 to about 105. Now when you guys are playing around with your amps, getting used to the heat that you want, you have to practice, get a couple pieces of scrap metal steel that you're going to be welding together. This way you can dial in the heat, because it's all on you. If you're a faster welder, you're going to want to have the amperage up. If you're a little bit slower, you want to have your amperage down a little bit. So that's key to you, what your feel is setting the heat, or what we call the heat or the amps on the machine. So that's our rod selection. Then we have our machine setup. Now when we're out in the field with a regular welder, we're generally doing structural steel, so heavier steel. So we're doing what they call direct current electrode positive. That's when we hook up our leads with the negative to the ground, to our workpiece, and then our stinger or our electrode to the positive side of the machine. That's generally what we use out in the field, and that's what they call reverse polarity. The reason why they call it reverse, like I said, everybody always thinks when you weld, the electricity actually goes from your stinger to the ground, but that's not how it works on reverse polarity. It actually goes, your electrode, your current goes from your negative side or your ground side all the way around up to your electrode. So that's why they call it reverse polarity. But what we're going to be doing is, we're going to go to direct current electrode negative, or that straight polarity. This way, when we switch our leads on the machine, you actually have to switch your leads on them. The current will be going from our stinger to the ground. Can anybody tell me why we do that?
For thinner metal.
For thinner metal, but why, Marcus?
So the heat don't go into the piece as much.
Right. Yeah. Got that right. Because generally what happens is we have it on direct current electrode positive. As the currents go through, it heats up the piece of the steel that we're welding on. So the heat actually starts moving, or the molecules inside the steel start moving so they heat up. So then our arc gets a, and that's good with a thick steel. You actually want warmer steel when you're welding. Sometimes we preheat our steel, right? But with thin sheet metal, especially like right here, this is an 11 gauge sheet metal. You don't want to heat this up because then you're automatically starting to heat it up and then it'll start melting on you. And then when you actually go to time to weld, you'll be blowing holes. So that's why we go to direct current electronegative, and that's what we call a straight polarity. So whenever you weld on thin sheet metal, you want to be on what they call a straight polarity. Now some machines actually have switches where you can do that, but generally the welding machines that we have out in the field, you're actually going to have to switch to leads. And that's all it is. And after we do our little lecture here, we'll go down to the shop and I'll actually show you how to set up a weld machine on that, all right? So we went over our rod selection, how to set up the machine. Now we're going to go over some weld symbols. We touched a little bit on them last year, remember them? So the American Welding Society has a standard that you have to follow out in the field. As you guys can see up there, I have my your base and your arrow with your numbers and your rod selection. So when you're reading these things, right here, this is our weld symbol. So we have our baseline with a little flag and an arrow pointing to a spot. So what this is telling me here is what I'm going to do is, it's a field weld because that's what that little flag there is. And then on either side, because that's what the double little triangles mean. So either side of this angle clip, I'm going to put a 3/16 fillet weld. And the fillet weld is that little, the thickness between the pieces of steel, almost like an angle. So this will be like 3/16 thick from the toes to toe. Remember the two ends of the welds are toes, and that middle part is the leg. So from toe to toe in the leg, it's going to be 3/16 thick. And then if you notice right here on the back side where the on the base side arrow, I got my 1613 rod, 6013 rod, and we're using an 1/8 inch thick rod. All right. So that's how we read our weld symbols. Now, when you get a blueprint or anything, when you're building or welding something, it's going to have the different style weld symbols all over the place. So right here, I have it set up as a front view on our post, because if you guys remember on our conveyor project downstairs, when we were setting it up, we had our different clips to hold our headers in, and the different supports on our conveyor. So right there, it's saying a 3/16 fillet weld on both sides of the angle clip with a 6013 rod and an 1/8 inch thick. And then on the other side, you see where I have the post and the header. You have the same thing. You got the weld symbol down here. So it's a side view of your clip instead of the front view. So on both sides, because I have two triangles here, it's two-sided weld on the angle clip on the verticals, and they're going to be 3/16 fillet weld, field weld with an 1/8 inch rod. Now the way you read these symbols is, see how I have the arrow pointing here, it's pointing on that side, and then I have two fillet welds, so it's both sides. Then right here, if you notice, on the toe of the angle, right, I have my little flag that's with field weld, and then I just have one triangle. That means there's just going to be one weld on the toe. It won't be on the other side, it's just on the one. And then, of course, the 6013 1/8 inch thick. All right. So that's how you do your weld symbols. Anybody have any questions on those yet? You guys understand that? Okay. So then after that, you guys know welding is a big thing about angles and travel speed and all that. So whenever you're welding a thin gauge to a thick gauge, usually when we weld something, especially with like 7018, our work angle, we want to be on a 45. But because this one, it's going to be a downhill vertical weld. So what I want to do is have my angle, or my travel angle, on like a 20 to 30 degree angle down. And that's another thing. When you weld 6013 or 6011 on a vertical one, you generally go downhill. You don't go uphill, because if you go downhill, the heat's going to stay below it instead of being on top. So when we do 7018 vertical, so that as we go up, believe it or not, the heat's building up in front of your rod, and it's making the steel hotter. So when you're welding thin sheet metal, you don't want to be going up vertical. This way, as you build your heat up, it actually starts blowing through on that thin steel. So that's why we go downhill. In 6011 and 6013, you can manipulate downhill. So we're going to be at about 20 to 30 degree on a downhill, and when you guys also come in to weld, you're going to want to keep tip of your rod, pretty much concentrate your heat for your rod angle more to the angle, to the thicker steel. And then you're just gonna manipulate your puddle left and right. You know when you guys do 60-10, you do a whip and pause up and down? This one will be like a whip and a wiggle bit left and right. Put more of your heat onto the angle, because the angle's thicker, so it can take more of the amperage, right? And then just real quick whip over to the thin steel. So as you drag it down, just a little bit left and right. But when you're doing left to right, just hold a little bit longer on the thicker angle piece, okay? And then also, when you're welding downhill, you guys know what the puddle looks like. It's that bright, bright light, the orange, that bright orange at the end of your rod, at the tip. So as you come in, you want to keep your arc length, which is your distance from the plate, about a 16th. You don't want to go too close into the steel. You don't want to actually lay it on the steel. You want it off just a little bit, which would be about a 16th of an inch. And then I'm also going to be paying attention to my puddle and then the slag. So you can actually see the slag above your puddle. That'd be like a light gray, almost dark color. So you want to keep that like an 1/8 inch above your puddle. You don't want to let the slag start building into your puddle, because then you'll get porosity. So what I did was here was welded up a little demonstration piece so you guys can see what a good weld and a bad weld looks like. So on this side, when I weld it down, I kept it at like a 20 degree, a 16th off the steel as I welded down, and I wiggled left and right a little bit. And like I said, I concentrate most of my heat onto the angle. If you can see, I have a nice bead right here. I have no undercut on the thin sheet metal, and I don't have any undercut on my angle clip. So I was keeping the right angle, the right speed, and everything at the same time. Now it's kind of hard as welding because we're not machines. We can't maintain that 16th of your arc length all the way down because you're losing your rod. So you got to get in good practice and be able to go straight down, keep the same travel angle, and then you correct the arc length at the same time. And that takes some practice, and we'll be doing that today in the shop. And then on the other side, what I did on purpose, not on purpose, but a little bit by accident, when I was wiggling my left and right, I didn't hold to one side too long. I held more on the thin than I did the thick. And then I pulled out a little bit. I didn't keep my arc length at that 16th. And you can see some slag here. So I'll pass around. You guys could actually see the difference in a good travel and work speed to the other side where it's not. And if you guys also pay attention to the back side of that thin sheet metal, you can see where I actually got a good burn heat trace on it. So I know I have good penetration on both the thin steel and thick steel. So that's the hard part. And that takes practice. It's not going to happen overnight. It takes some time. Sean, you know very well, welding is like an art form. It's a whole different trade on itself. You need a lot of time under the hood. But if you guys can get this down when times are slow and there's not that much work out there, the carpenter shops like the PDMs, the other panel shops, they're looking for good welders. Back in the beginning when PDM was starting with the Great Wolf Lodge down in Maryland, they mainly had a lot of millwrights welding for the carpenters. Now the carpenters come up here at night for welding training, and they're starting to get more carpenters on the job. So this is a really good skill to get to have in your toolbox so you can have to get on jobs. You'll be in high demand. So, does anybody have any questions on anything?
Is there a certain way you're supposed to manipulate the rod, or are you supposed to go straight down or do circles as you're going down?
So generally when you're doing this, like when you're doing a horizontal or like a 60-10, when you're manipulating the puddle, you want to go left to right on a horizontal. So when you're doing this on a vertical one, so I said to Sean, what I'll do is I'll come in, I'll be on my 20 degree work angle, and I'll concentrate more on the angle clip, and I'll go left to right as I go downhill, but holding the side of the angle a little bit longer than I would on thinner steel. So you do manipulate the puddle left to right a little bit. It's just a little wiggle. You don't want to get too drastic because then you'll get the porosity inside. That's the hardest part about this. 6013 rod is very finicky. It's the high, it's hard. I was very frustrated when I was welding with this a couple weeks ago. You know, like this, I'm so used to 7018 or structural steel welding. That's so easy because you can lay the heat in there, you get that puddle going. We all know how it feels to get that good bead going. Excuse me, that good bead going. We're all like just right in the groove. With this one, it's so finicky. Everything's got to be right. There's a little bit more forgiveness in the other style rods, but this one, you got to have everything right. And that takes practice. So did I answer your question with that?
No.
Okay. So what we're gonna do now, guys, is we'll head down to the weld shop, and I'm gonna show you or demonstrate to you guys how to set the machine up. All right. All right. Now here we are in the weld shop. So after up in the classroom, we went over theory, why you use the different rods and the different heats that you set up and the different ways to set the machine up. So now what I'm gonna do to you, or show you right now, is how to really set the machine up. But the first thing that you have to do whenever you come into the weld shop is to your PPEs, your personal protective equipment. So whenever you're in the weld shop, you definitely have to have your Z87.1 safety glasses on, because there's always gonna be metal flying around with people grinding and all this stuff. So you don't wanna get no metal in your eye. So we definitely want our safety glasses. And then you're also gonna want your burning jacket, because you're gonna be doing a lot of welding and burning and cutting. This way it protects you from getting sparks or burns. So I have my approved welding jacket on with some leather sleeves and a nice fire retardant jacket. Always want to make sure it's buttoned up all the way. I always button my buttons all the way up to the top on my neck, because when we're doing overhead welding, we don't want no sparks coming down, and sometimes I'll pull my collar up to keep anything from coming inside. Also, when you're welding in the shop, in school we keep the dress code where we have our pants tucked, our shirt tucked into our pants. But whenever you're in the weld shop, you can pull out your shirt. This way, nothing ever gets stuck under right here on your belt line, and you don't want to get no sparks or slag or molten lava burning right down here. This is a spot where you'll get burned a lot, and you don't want that, so untuck your shirt. And also your jeans. If you notice here, my jeans are all nice. I have no frays, no tears, no little spots where I can have like a wicking or a fire effect, so I don't catch on fire. And then of course, I have my leather work boots on. This way when the slag comes down, I don't get my feet burned. And then you always have to have your welding gloves on, or some sort of heavy duty glove, leather material. This way you don't get burned. So now, we have our PPE on for our body, and now we're gonna go over our shield real quick. So this is my auto welding shield. Whenever you weld, you're gonna wanna have your shield set to a 10 shade. So inside you can have your different dials and adjust your shade for your for welding. Generally, when you weld with regular mild steel with a stick, you're going to want to be on a shade 10. If you're doing like some other welding like TIG or something with a higher amperage rating, you're going to dial your shade up to about 11 or 12. You just want to get it a little bit darker so you don't get any of that flash in your eye. You never want welder's flash. Now what's also nice about these auto shields is some of them have either a switch up here on the side or inside on your headrest. There'll be a switch inside that will either go from weld to grind. So you switch that over if you're going to be burning or grinding. You can switch it over to grind. This way it doesn't automatically go dark on you and you can't see what you're doing. It stays at that light shade 10 so you could actually see what you're doing. And your head and your eyes are totally covered. So it's good to always have a shield covered in. If not, we have what we have over here is just a regular burning. This is a shade 5 burning shield. This way you could burn your steel with your torch and you can protect your eyes. And then real quick, you could also have this if you want. This is a clear shield. So whenever you do grinding, you just use your clear shield. This way you protect your eyes too. Your eye safety is big in the weld shop. So real quick, what I'm going to do is show you how to set the machine up for straight polarity, like we went over up in the classroom. The difference between reverse and straight polarity. So if you remember when we were talking about up in the classroom, straight polarity is where I'm going to switch my ground to my stinger instead of having my ground right to my ground clamp. So right here I have my stinger and my lead. What I'm going to do real quick, just go over it, give it a visual, make sure everything's tight here on my welding lug. This goes into the machine. I'm looking for no defects in the lead, so I don't want no kinks, no chafering, no cuts, no abrasions. So I'm looking it over, make sure everything's tight, connections are good, checking the jaws, looking at these plastic covers, making sure they're not cracked or the jaws exposed. This way, if anything happens, if you put it down, it won't arc out on the table or the piece you're welding. So this lead is pretty good in the stinger. So now what I'm gonna do, is I'm gonna get my welding lug, the male end, hook it up to the machine. If you notice right here, I'm gonna go to the ground, twist it in, turn it in, make sure it's tight. So now my stinger lead is on the negative side. Same thing with the ground clamp. I'm gonna grab it, just give it a once over, make sure everything's good. Ground clamp's good, no, it's not melted or defective. Everything's tight here. Looking at the lead, making sure everything's good. No shapes, no cuts, no abrasions. Everything looks pretty good to me. Now I'm gonna hook this up to the positive. Make sure it's in there tight. Now, remember, now we have it on the DCEN negative, which is straight polarity. And this is what we weld when we weld 6013 and thin sheet metal. So I'll put that over here. Now if we're welding like structural steel, we would switch it back to reverse polarity. That's where you normally see the welding lead, your stinger on the positive and then the ground on the ground. But since we're doing 6013 thin sheet metal, we have it on straight polarity and we reversed our leads. So real quick, before we start, I'm not going to turn the machine on. I'm going to have it on the off position. I'm going to go over my machine, make sure all my settings are on. I have my local, which means it's just for the box, and my welding leads. Instead of the remote, if we would be like TIG welding or something else, we would switch it down to the remote and hook up our TIG pedal. But since we're just doing regular stick welding, I'm going to have it on local, and then right here, you also have two switches either for stick welding or for TIG. If I was TIGging, I would switch it down to TIG, but since we're stick, I'm gonna keep it on the stick. Our arc force, generally, especially with thin sheet metal, you're gonna wanna stay at arc force 0. You don't wanna move this dial at all. Keep this at 0, because what happens with arc force is that is a deep gouging. That helps get more penetration. So, like I said upstairs, we don't want too much penetration on the thin sheet metal. So I'm gonna keep that at 0. My hot start, I'm gonna have that on. That's to give me my initial start with my rod when I hit the ground or strike the arc. That just ramps up the amps on the machine, just about like 5 amps, just to give you that initial start to go. So I'm gonna have my hot start on. Then, like I said upstairs, my amperage, we're gonna be doing an 1/8 inch rod at 6013. So I'm gonna dial my amps up to about 90 to 85. This one's an analog style. The digital ones are a lot easier. You can actually dial them into like the perfect amp that you want. But I'm just gonna put this somewhere around 90 for right now. So once that's all done, all set up, I go where the machine's at, where it's at on the amps, all my settings. I'm gonna switch my machine on. Give it a couple seconds. There's 2 lights on the machines when they start up. You got a temperature one and then the power one. They both go on. And then once the machine gets running, gets warmed, then the temperature light goes out and my green power light comes on, and I'm ready to weld. So what we'll do, guys, is cut up a couple of pieces of scrap and we'll set our heat, and then we'll do some passes.